My name is Parnagam RPSD and my IT number is IT20254384. So in this Recase software development assignment, my contribution is for fixing vulnerabilities in injection attacks and for the server-side request forgery attacks. So there are some multiple number of forms in this application, so it might cause some vulnerabilities in the existing application. So first I started the injection attacks. So injection attacks are in the most type of like cross-site scripting and so SQL injection and the XSS. So in the existing implementation in this create feedback function, there is no any validation in the backend application. So user can input any data. So here I have added the validation for email, mobile number, and the rating. And also I have sanitized the user entering descriptions and the name. So it will validate and sanitize those user inputs. And also in the get feedback report function, user can input any date field, so start date and end date. User can input any data. So it might cause to some NoSQL injection attack. So here I have added the validation for date field. So then it will only accept the date format. The format type is the date. So user can only input the date from this request, and otherwise it will throw error message as the date format is invalid. And next, I will move to the server-side request forgery. So in the server-side request forgery is about sending malicious requests to the backend application, and this might cause some data exposure, service interruption, and even for the total compromise of the system. So in the update feedback function, uh, in the earlier existing application, there is no any validation for user entering ID, so it does not validate the entering ID, and so user can enter any type of data. So I have added the validation for invalid checking IDs, and also in the previous application there is no any uh, methodology for sending the messages. So it always send the error messages with default error messages which some exposed data. So I have added the predefined user error messages. So this does not compromise any internal structure of the application. And also I have added the sanitization and user input validation. So this also prevent from performing the server-side request forgery attacks in the application as well. So that's the implementation I have done. Thank you very much.
Hi, I'm Ranveer RMSH. My IT number is IT2025,000. In this secure software development assignment, my contribution is vulnerabilities is fixing the security misconfiguration and timing attack. That is server-side request attacks. First, I will start from the security misconfiguration vulnerability. So, security misconfiguration is a standard security issue that occurred when an application, server, or a software system is not configured correctly, leaving it vulnerable to various security threats. It is considered one of the top security risks because it's often result from oversight or negligence rather than a direct attack. So let's go to the existing vulnerability on the application. As you can see here, the primary vulnerability in the application involved improper handling of JW tokens and security keys at the database credential. So from the user controller .js, I have gathered there is a so I have gathered there is a exposing there's a hard coded JW token key here. So the exposing sensitive JW security key and database credential directly in the source code is a severe security misconfiguration. Unauthorized access to JW security keys so can allow the attackers to forge JW tokens and potentially gain unauthorized access to the protected resources. And another vulnerability I found is from the server.js, that is this connection .url for the MongoDB. So exposing the database credential may result in unauthorized access, leading to the data breaches and potential loss. So how so overcome this vulnerability? How I did the fixes? So as you can, I can show you. From the user controller.js, I store the JW security key in an environment called .env file and access it using the library like .env. I do not hardcode the security key in the source code. I will show you. As you can hear, this is the token and JWT. So from the .env file, I'm suppose from the .env file, I'm getting the data to the user control JS. From the server side, I did was protect the database credentials. That is, this is the earlier vulnerability. So I did modification to the process.env connection URL. From the .env file, I'm getting the data to here. So those are the vulnerability I did, and also I used the environment variables. I modify the application code to read sensitive information, like example, database security key, database credential from the environment variable. I used library site.env to load the environment data from the env file. Another thing is access control for secrets. That means implement access control and permission to restrict who can access the sensitive information like environment variable contains security keys. And those are the principle I follow to ensure that is only unauthorized personnel can access these secrets. So the first another one is security regular security audits. Conducted regular security audits can code review to identify any instance of exposed security information in the code base. So that is from the first security misconfiguration vulnerability I did. Let's go to the timing attack. So the timing attack is a type of cryptographic attacks that exploit the variable into the time that take for a system to respond to different inputs. It's a primary used to reduce sensitive inputs such as cryptographic keys or password by analyzing the timing dependencies in the application response to the variable inputs. So the what are the vulnerabilities in the on the application? The potential timing attack vulnerability in the application relate to the password validation process. In the provided code, the application validate password using custom function name validate password. I can see under the user controller, there is a validate password function validate password. So the function check if the password meets certain complexity requirements, such as length, presence of the special characters, and numeric characters. While this function ensures that password is sufficient complexity, it does not have any time-related vulnerability itself. So however, over the large number of attacks, an attacker could potentially detect the correct character of the password based on the response time, because of the albeit is very slow. So how I overcome this vulnerability is to mitigate the timing attack vulnerability password validation process. It is recommend to use a consent time comparison function for password checking. A consent time comparison function ensure that the time is take compare valid or invalid password remain the constant. As you can see here. So this is the function validate password I showed you earlier. So to overcome this one, so I have written the function compare password, that is comparing the input password and stored password. Length is equal to the stored password and return false. Likewise, this is the compare password function to secure compare use inputs faster to store hash password without leaking timing informations. So that is the one. So conclusion from this timing attack vulnerabilities: identify the application relates to the password validation process. It is essential to implement constant comparison function to mitigate this vulnerability. Furthermore, it is crucial to maintain vigilance and addressing security issues and staying up to date with security practices. So this is from my side. Thank you.
Hi, I am Dilishan AVR IT 2005276. Uh, in our web application, I fixed the two vulnerabilities. First vulnerability is insufficient login and monitoring. In here, I do some activity. In previously, our web application can't monitoring user activity. Now I fix that. Then user activities are saved in .log file. In here, all the activities and the web URLs and the PC network addresses, user details are saved in the .log file. I create the model for that, and I give the .log access file path in the middleware folder in the logger.js file in here, and I call the API in the server.js file, and I use the Morgan for that. Then I move to second vulnerability that I fix. Second vulnerability is insecure uh, object direct object reference. In that this is the admin page. In the admin page, user can only see the user management, product approve management, and the feedback management pages. Others can't see that pages. So that I log out and log in as a buyer. This is the buyer page, and any other users and or buyers can't see the only access that have admin pages in here. So I edit the web URL for user management like this. It will redirect to 404 not found page. So I do this using front-end web app.js file. So I give the some conditions for you only access pages in here. These routes are only access for admin, and others are redirect to 404 not found pages. Thank you.
I'm Gamage BGJ. My IT number is IT20402266. So in this video, I'm going to explore on the vulnerabilities that we have found and what we have done to prevent them. So in my case, I have found the broken access control vulnerability and a cryptographic failure vulnerability. So in this application, let's go to the broken access control vulnerability. So in this application, in the server.js file, there is an existing potential security issue regarding the chorus configuration. The problem lies in the following line of code. As you can see, in the previous one, it is mentioned like this, and it do not holds any configuration at most. It is public. So for the solution, I have implemented allowed origins. So I have specified the allowed origin and configure the chorus explicitly define the origins that are permitted to make requests to the server. So this can accomplished as here. So it is only for the localhost 3000 and the chorus options. If it is okay, it can continue. If it is not allowed by the chorus. So that's from the chorus policy. So using that concept, uh, so by implementing these corrective measures, the application can effectively address the broken access control vulnerability associated with the chorus configuration, thereby enhancing its security posture in production environment. So let's go to the cryptographic failure. So in this application that we have used to in this existing application, the primary vulnerability in the application is associated with the improper Stripe API key handling. So it is used in the payment route.js. So in here, as you can see in the previous project, it is as the public key. So it cannot be a public key. It should be a private key. So so I have fixed it by adding that key to the .environment file. So anyone can't access these keys. So the file will be used to store sensitive information, including the Stripe API key securely. So that's from that, and the by configuration in the .environment in the application, I can access by it process.env.stripe API key. So it is hide from the users, but it can be usable. In the conclusion, as the implementing the use of environment variables and .tne file for securely managing sensitive API keys is a crucial in fortifying the application security posture. So it prevents cryptographic failure vulnerabilities and ensures that sensitive data remains confidential and protected from potential threats.